Conditional probability. All right, there's one state standard that goes along with this lesson. And the success criteria, which you need to be successful, you need to be able to explain the meaning of conditional probability. You need to be able to find conditional probabilities. And you need to be able to make decisions using probabilities. One new vocabulary, conditional probability, the probability that an event B occurs given that event A has occurred, is called a conditional probability of B given A and is written as this. You can see here in the definition, I had to draw a line here. So just kind of, that just is my way of trying to make it look like this right here. All right, so conditional probability. So B given A has already happened. So there's some kind of condition when you have conditional probability. All right, there is a formula, so conditional probability in words. For two events, A and B, the conditional probability of the second event given the first event is the probability that both events occurred divided by the probability of the first event. And you can see with math symbols, this is how you would write this for conditional probability. So the probability of A and B divided by the probability of A. Example 1, using a sample space to find a conditional probability. A family has 2 dogs and 2 cats. They randomly select a pet to get brushed and then randomly select a different pet to get a treat. Find the probability that they select a cat to get a treat given they selected a dog to get brushed. All right, so find the probability that they select a cat to get a treat and they select a dog to get brushed. All right, so the first thing we can do is say with 2 dogs and 2 cats, let's go ahead and give these, we'll use a symbol. So we'll use D1 for dog 1, D2 for dog 2, C1 for cat 1, and C2 for cat 2. So we have 4 pets, 2 dogs and 2 cats. So they randomly select a pet to get brushed and then randomly select a different pet to get a treat. So they're selecting one pet at a time. Find the probability that they select a cat to get a treat given, that means this has already happened, that's the condition, given that they selected a dog to get brushed. All right, so let's look at our different outcomes, all right? So let's see, what could we have? So if we make a table, we want to just kind of organize our information. So we want to select a cat given the dog gets a treat. So let's say we start with, we have D1 and D2, that represents our 2 dogs. So we're going to start with D1 and cat 1, dog 1 and cat 1. And then we're going to have dog 1 and cat 2. And then we're going to have dog 1 and dog 2. So that's all the different combinations where D1, dog 1, is picked first. All right, so then we're going to have dog 2 with cat 1, dog 2 with cat 2, and dog 2 with dog 1. All right, so that's every combination given that our 2 dogs are picked first. All right, so what may happen, maybe we start with the cats. So let's say cat 1 and dog 1, cat 1 and dog 2, cat 1 and cat 2. So that's every combination where cat 1 is picked first. And then we have one more pet that could be chosen first. So cat 2 and dog 1, cat 2 and dog 2 and cat 2 and cat 1. All right, so this is all of our different combinations that we could choose if we choose these randomly for a cat to get a treat and a dog to get brushed. So now what we're looking for is we want cat to be second. All right, so the cat is given a treat. Given, that means this has already happened. So we're looking for the probability of cat second given dog first. All right, so let's see what we have here. So if we look, we have all of these have a dog first, right? So that's this part here. And then which one has a cat second? So we've got 1, 2, 3, 4. So 4 out of 6, which equals 2/3. And if we round that, that's going to be about 0.667. So it's about 66.7%. You need to use your calculator to do that. That's fine. I look at 2/3 and 1/3 and those numbers all the time. So I know that's 66.7%. All right, so conditional probability. This is something that doesn't come really easy to me. This is something I have to work at. So if you noticed, I had to reread the question multiple times in order to just kind of process that in my head. And that may be something that you need to do as well. This may be something you really like, but for me, this is something I have to work at. Even as a math teacher, some things come easier than others. Example 2, using a two-way table to find conditional probabilities. All right, so I like using the table a little bit better than like in the last example where we have to list all the outcomes. When I have to list all the outcomes, I always am afraid I'm going to forget part of the outcomes or not include everything. So when you have a table, this makes it a little bit easier. A quality control inspector checks for defective parts. The two-way table shows the results. Find each probability. A part, find the probability of pass given defective. B part, find the probability that fail given non-defective. All right, so let's look at A first. All right, so if we're going to look at A part, we want to look at the ones that pass given that they're defective. So we know that this many here are defective. So 3 plus 36, that's 39 parts are defective. So how many pass out of the ones that are defective? So the ones that are pass, you can see there's 3 out of 39. And then we can reduce that to 1 over 13 because 3 does go into 39 evenly. And that's going to give us about all right, so we've got 1, divided by 13. So that's going to give us about, again, decimal, make it a percent, you move it over 2 decimal places. So that's going to be about 7.7%. So that's going to be about 7.7%. So again, using the table, as long as you're looking at the right stuff in the table, using the table is a little bit easier in my opinion. All right, B part, let's see what B part says. We want the probability that fail given non-defective. All right, probability of fail, okay, we have one column here that's fail given non-defective, and here's non-defective. All right, so we're going to have this column here is our non-defective parts, and fail would be 11 out of that. So we're going to have 11 out of 450 plus 11 is 461. And I don't know if that reduces or not, but we're just going to put it in the calculator and see what kind of percent that gives us. So let's see here. So we're going to have 11 divided by 461. And that's going to be about 2.4%. That's going to round to 2.4. So that's going to be about 2.4%. All right, so again, conditional probability, there's always a condition to what you're looking at. So we want to know how many failed with the condition that we're only looking at non-defective parts for B part.